going to do problems 7-2, 1 through 4. And so we're thinking about volumes now, and our basic idea is that the volume of something, some solid that was created by rotating a curve around the x-axis or the y-axis is, it's like the sum of all these little cross-section slices, and those are all going to be disks, or maybe like washers if it's a hollow type. So that's going to be basically like a pi r squared kind of thing, where we're going to integrate from whatever. Let's say if we're rotating around the x-axis, then it'll be like x values, and it'll be a dx problem. And then let's say, actually, let me make this a big R. And then maybe if it's hollow, then we'll also be doing minus like the smaller inside radius. And if it's rotated around the y-axis, it's like this, but it's a dy problem. So we're just integrating across these pi r squared slices. So let's try a few examples here. Number 1. We got rotating around the x-axis, so this is a dx problem. And so I just need to figure out what the r squared is. I guess I just really like making little sketches of these things, don't you? So, oh, that's pretty decent. We're rotating around the x-axis, so that means it's going to get flipped around down here and rotate like this on the page, so could make little cross sections here. So what does this look like? It looks kind of like a bullet, I guess, or what are other things that are this shape? Something like that. Yeah. Gumdrop. How about that? And we're ready to fill this in now. So the radius of this is just like the value of the function, right? So pi times r squared, but that r is going to be the value of the function. And the value of the function is the square root of 3 minus x. And it's pi r squared, so that's going to be nice because that square root sign is going to go away. And now look for x values that we're going from where to where. It looks like we're going from -1 to 3. All right, and that's the setup for it. Now we just have to try to do it. 3, that's just going to be 3 minus x dx. And antiderivative of 3 is 3x minus x squared over 2 from -1 to 3. And that's pi. Oh, I forgot to write my pi there. Pi. Plugging 3 in here, I get 9 minus 9 halves minus let's see, -1 in here, that's going to be -3. Got to be so careful with signs. -1 squared is 1, that's minus 1/2. Okay, so let's see, that's 9 halves minus -3 minus 1/2 is -7 halves, right? And then that's really going to make it plus. So plus 7 halves. 16 over 2 is 8. So it looks like we got 8 pi here. Sorry, I'm off the screen maybe. Sometimes I can't tell. It's like it's off the screen, and then when I get it onto YouTube, the screen's bigger than I think it is, or bigger than what I can see. Let me just flip to the answer page here so I can make sure I'm not giving you any fake news. 8 pi is the answer. We're good. All right, so the second one, going to be rotating the line, let's see, we're rotating around the x-axis again. Let me make a sketch first before I start jabbering about it. All right. right? So it looks like when I rotate this around the x-axis, this is going to make a hollow thing. Like this. You ever seen those like little putting practice, like golf putting practice? Like the little thing you put on your floor and in your fancy office when you get tired of looking at the amazing view out your big corner windows. You put this thing on the floor and you take out your putting equipment. I guess that's like a golf ball and a putter. And then you put this thing on the floor and you putt golf balls and you try to get them to rest in that little thing. That's what that could be, I guess. That's my, lampshade's like a good go-to for any of these. This is solid, so I don't think that would make a very good lampshade. And this, I guess if you were like upside down or something, if it was upside down, or I guess if you were upside down, it could work. So let's see, I'm going to have like the outside radius squared minus the inside radius squared here, right? Because it's one of those. And where am I going from? It looks like I'm slicing across, what are my x values, from 0 to 1. Right, it's a dx problem, so I'm looking for slicing across the x-axis. And the outside radius is this function. That is y equals 2 minus x squared. 2 minus x squared. And then that gets squared. And then the inside radius is just this, y equals x, which is that. And don't forget the pi on the outside. Okay, so that's the setup for it. So let's see, what do we have here? If I square this, I get 4 minus 4, that's funny, you say 4 and you write down a 2. 4 minus 4x squared plus x to the 4th minus x squared. So simplifying all that, it looks like I got 4 minus 5x squared plus x to the 4th dx. And that's going to be, don't forget your pi, 4x minus 5/3 x cubed plus x to the 5th over 5 from 0 to 1. And when I plug the 1 in here, I'm going to get 4 minus 5/3 plus 1/5. And then when I plug 0 into all those, it goes away. So let's see, how do you want to do this? I guess we should get a common denominator. So common denominator would be 15. So that's 60 over 15 minus 25 over 15 plus 3 over 15. So 60 minus 25 is 35 plus 3 is 38. And I'm kind of on a bad streak here with the forgetting the pi. You're really not supposed to go through and just stick it back on at the end like I'm doing because you might forget. So please do a better job than I am keeping track of that. All right. How about this one? Got a little trapezoid type thing. It looks like something like that. We're going to rotate around the y-axis. That means it's a dy problem. It's not hollow. So, so there. And this looks like, well, I'll tell you what it looks like. It looks like, well, it looks like a lampshade, but it's not hollow, so it's like a lampshade before they hollowed it out. Or it's like the science, your science fair vinegar and baking soda volcano. How about that? or the little megaphone thing that the cheerleaders yell into at football games, or that the director yells "cut" into on the set. You got some options there. Okay, so now be careful with these numbers here. We're slicing now because this is a dy problem. We are slicing across the y-axis, so you have to make sure you choose y numbers. It's not from 0 to 1.5. Those are x numbers. It's 0 to 2. That is the range of y numbers that we are slicing across here. And they have y equals 3 minus 2x. Now I can't put something in here with x's. Now y equals 3 minus 2x. I have to get this into the right form to put in here, which means that this has to be an x equals form if this is going to be a dy problem. So I'll just just do a little algebra. So x is equal to 3 minus y over 2. Minus y over 2 squared. All right. And when I square the 2 on the bottom, that makes it a 4. So that's pi over 4, and that's a constant. So I'm just going to bring that to the outside. And then I'm going to have the integral from 0 to 2. You don't have to do that. I just think it makes it easier. And then I have this thing squared. That's 9 minus 6y plus y squared dy. So pi over 4 times 9y minus 3y squared plus y cubed over 3 from 0 to 2. So the 0 is nice. I don't have to worry about that. I just have to plug in this 2 here. So pi over 4 times 18 minus 2 squared is 4 times 3 is 12 plus 8 thirds. So that's 6, and that's, let's see, 6 is the same as 18 thirds. So 18 thirds plus 8 thirds is 26 thirds. So pi over 4 times 26 thirds. 13 pi over 6. Peeky, peeky. Oh, that's the right answer. All right, we can do math. Remember that you can leave your answer for the College Board and therefore for me, because I am their servant. You can leave it like this. Number 4. This looks like rotating around the y-axis, but it looks like it's going to be holler. So 2, going to be slicing. We have to make sure we have y numbers to slice from where to where. What's this? Oh, I know what it is. This is the, did you ever see the movie Close Encounters of the Third Kind? If you haven't seen that, it's classic Steven Spielberg around the time when he made E.T. around back in the, early 80s? That could be late 70s even. Anyway, there's a guy, Richard Dreyfuss, he's a famous actor, that it's aliens. Close Encounters of the Third Kind. That means an encounter with aliens. So there's aliens that come to the Earth, and there you go. But he makes this. There's a geological feature in Wyoming called the Devil's Tower, and I think that's where the aliens end up landing. And this guy somehow, like the aliens are. I haven't seen this in many, many years. The aliens are communicating with him. And he knows that they're going to be at Devil's Tower, or somehow like that's in his subconscious. And he's sitting there at dinner with his family. His family thinks he's gone completely nuts. And he makes a sculpture of Devil's Tower, which is this weird, I mean, it looks kind of like this. It's like a mesa, but it's, you have to look it up. Look up for a picture of Devil's Tower in Wyoming on the internets. And anyway, he makes a sculpture of Devil's Tower out of mashed potatoes on his dinner plate. And, you know, he does it with his fork. It takes him a while, I think. So this is like if you wanted to make a Devil's Tower sculpture out of mashed potatoes, this is just like a shortcut. You know, it makes it a little bit easier. You just pack the mashed potatoes inside this thing, because this is all hollow in here. And then you flip it over, and bonk, there it is. Mashed potato Devil's Tower. Got to look that up, though. Okay, so what are we looking at here? We have a hollow thing, and that means it's going to have something outside radius minus inside radius, and it's rotating around the y-axis. That means it's a dy problem, which means this has got to be all y stuff. And since it's a dy problem, these need to be y numbers. So looking at this thing, it looks like we're going from 1/2 up to 2. And it looks like the outside radius, that's like furthest away from the y-axis, is just the constant 2, right? It's just this line x equals 2. Remember, these are things that are in like x equals form. So it's just 2, right? You can see that radius is not changing as we slice across here. The outside radius is 2, 2, 2, 2. The inside radius is, well, if y equals 1 over x, algebra x equals 1 over y. So this is 1 over y squared. That's the inside radius. All right. So let's see. This is pi times the integral from 1/2 to 2, 4 minus y to the negative 2 dy. That's pi. So the antiderivative of 4 is 4y. And the antiderivative of y to the negative 2, this is one that seems to cause more little mistakes than it should. Bump the exponent up 1, that goes to negative 1, and then divide by the new exponent negative 1. So all that does is change the sign to positive y to the negative 1. All right. Now pi. Plugging 2 in here gives me 8 plus 1/2. And minus, plugging 1/2 in here gives me 2 plus 2. So let's see, was that 7 and 7/2? That's 8 minus 4 is 4. Oh, no, just kidding. 4 plus 1/2 is 9/2. So 9 pi over 2. I'm thinking. And that's it. All right, so that's how you do these volume problems. It's a good intro to that. Only 4 problems, but that's a lot of stuff to do there. So if you're looking at your sheet and you have far less calculus written on it than this, then I don't know, maybe it's time to take a look at yourself in the mirror and write some calculus on the mirror. And then take a look at yourself again in the mirror, and it's going to look like you have calculus on your face.